Let us see the question carefully. If f of x is equal to x minus x square plus x cube minus x power 4 plus and so on up to infinity, when mod x is less than 1, then what is f inverse of x? The first option is x by 1 minus x, second option is x by 1 plus x, third option is 1 by 1 minus x, fourth option is 1 by 1 plus x. Well, that is the question. Let us first observe what f of x is. F of x is equal to x minus x square plus x cube minus x power 4 plus etc up to infinity. It is very easy to observe that this f of x is a geometric progression with the common ratio minus x. Luckily, we are given that mod x is less than 1. Therefore, the common ratio is modulus of the common ratio is less than 1. Mod x and mod minus x are same. So, the modulus of the common ratio, that is modulus of minus x here, is less than 1. Hence, this is an infinite GP in which modulus of the common ratio is less than 1. Hence, by using the sum to infinity formula, that is a by 1 minus r, let us recall the formula: a plus ar plus ar square plus etc up to infinity is equal to a by 1 minus r if mod r is less than 1. That can be grasped from geometric progressions. This looks like directly a geometric progression in which the common ratio is of course with absolute value less than 1. We can use that formula here. What is the first term? X by 1 minus, what is r? Common ratio minus x. So, this is x by 1 plus x. This is f of x. But we require to have f inverse of x. How to find f inverse of x? Let us recall the procedure. This is f of x only, right? What is f inverse of x? We have two types of procedure. Number one, let f inverse of x is equal to y. Implies x is equal to f of y. Implies x is equal to y by 1 plus y. Y by 1 plus y. Cross multiplying x plus xy is equal to y. X is equal to y minus xy. X is equal to y into 1 minus x. So, x by 1 minus x is equal to y. But y is nothing but f inverse of x. Therefore, this is nothing but f inverse of x. X by 1 minus x. That is, the first option is the right option. This is a fundamental procedure. There has been another procedure also to trace f inverse of x directly. What is that? Let us now observe. If f of x is equal to ax plus b by cx plus d, and assuming and believing that f inverse exists, then f inverse of x is equal to minus of dx minus b by cx minus a. An earlier mechanism. From the direct procedure, we could have derived it that one. F inverse of x is equal to. Let us now use this here. Here f of x is equal to x by 1 plus x means 1x plus 0 by 1x plus 1. In this format, in the place of a and b we have 1 and 0. In the place of c and d we have 1 and 1. So, by tracing this, f inverse of x is equal to minus of, come on, dx minus b, 1x minus 0 is x by cx minus a, x minus 1, x minus 1. Minus of x by 1, x minus 1. It can be written again as x by 1 minus x, which is similar to the previous answer. Like this, by using these two types of procedure, we can trace what f inverse of x is. Therefore, here the first option is of course the right option, that is f inverse of x is equal to x by 1 minus x. The next question. If f of x is equal to 1 minus x power n whole to the power of 1 by n and 0 less than x less than 1, n being an odd positive integer, then h of x is equal to f of x, then h of half is. Observe the question carefully. F of x is equal to 1 minus x power n whole to the power of 1 by n, 0 is less than x less than 1, and n being an odd positive integer, then h of x is equal to f of x, then h of half is. What is h of half? Before going to answer this question, in algebra we come across some self-invertible functions. What I mean to say is f is equal to f inverse, f circle f is equal to I, just like that. Here also we are having a same function of the similar type. Let us see what is the fate of h of x. What is h of x? H of x is equal to f of x. That is equal to f of, what is f of x given? 1 minus x to the power of n whole to the power of 1 by n. F of, this can be 1 minus, in the place of x, 1 minus x power n whole to the power of 1 by n whole to the power of n. 1 minus x power n. In the place of x we have 1 minus of 1 minus x. This is x. H of x is equal to x. H of x is equal to x. If h dash to x is required, it is 1. If h of x is required, h of x is x, h of half is half. H dash to half is required, so it is 1. As h of x is x, therefore h dash x is 1. H dash half is also 1. Hence the fourth option is the right option. What is the right option? Fourth option is the right option. The domain of the function f of x is equal to 9 power x plus 27 power 2 by 3 into x minus 2 minus 219 minus 3 power 2 into x minus 1 whole to the power of 1 by 4. What is the domain of the function? In the first option we have closed interval minus 3 to 3. In the second option, closed interval 3 to infinity. The third option is closed interval 5 by 2 to infinity. And the fourth option is closed interval 0 to 1. Here, we are supposed to have the domain of the function. This definition has a long appearance. F of x is equal to, what is that? 9 power x plus 27 power 2 by 3 into x minus 2. 27 power 2 by 3 into x minus 2 minus 219 minus 3 power 2 into x minus 1 whole to the power of 1 by 4. In this expression, the exponent is 1 by 4. 4 is an even number. In order to define that this function is valid, here the function is 9 power x plus 27 power 2 by 3 into x minus 2 minus 219 minus 3 power 2 into x minus 1 whole to the power of 1 by 4. the domain of the function is required. The first option is closed interval minus 3 to 3. Second option is closed interval 3 to infinity. Third option is closed interval 5 by 2 to infinity. And the fourth option is closed interval 0 to 1. Let us have a look over the definition of f of x. For this function to be defined, we must have 9 power x plus 27 power 2 by 3 into x minus 2 minus 219 minus 3 power 2 into x minus 1 must be greater than or equal to 0. This 9, you can have 3 square. 3 square power x is 3 power 2x plus 27 is 3 cube. That 3 and this 3 will be cancelled, leaving you 3 power 2 into x minus 2 minus 219 minus 3 power 2x minus 2 is greater than or equal to 0. Again, this is 3 power 2x, 3 power 2x plus 3 power 2x minus 4, that's nothing but by 3 power 4 minus 219 minus 3 power 2x by 3 square greater than or equal to 0. Among all these, you can observe 3 power 2x, a common factor. 3 power 2x into 1 plus 1 by, what is 3 power 4? 81 minus, what is 1 by 3 square? 1 by 9 minus 219. If you go the side, it is 219. Let us have a simplified form for this. Three power 2x into LCM is 81. 81 plus 1, 82 minus 9, 73. It is 73 greater than or equal to 290. Therefore, 3 power 2x greater than or equal to 219 into 81 by 73. 73 goes 3 times. This is 3. This is 3 power 4. This is equal to 3 power 5. Therefore, 3 power 2x greater than or equal to 3 power 5. Therefore, 2x greater than or equal to 5 implies x is greater than or equal to 5 by 2. That is, x belongs to 5 by 2 to infinity. Hence, the right option is closed interval 5 by 2 to infinity. This is of course a very simple algebraic transformations. Yes, by doing very simple calculation, we are able to trace the answer as the closed interval 5 by 2 to infinity. That is, the third option is of course the right option. The question is, f and g are two functions defined on the set of natural numbers such that f of n is 2n minus 1 if n is even and 2n plus 2 if n is odd. G is another function defined as g of n is equal to f of n plus 1. Then what is the range of g? He is asking us to find the range of g. For that, 4 options have been given. The first option is the set of all positive multiples of 4. Second option, the set of all even natural numbers. Third option, set of all natural numbers which are in the form 4k plus 3, where k is also a natural number. And the fourth option is the set of all natural numbers which are either multiples of 3 or multiples of 4. Range of g, how far does it range? We are supposed to find. Here g, the function g is defined with the help of the function f as g of n is equal to f of n plus 1. Let us observe the range of g. G of n is equal to f of n plus f of n plus 1. This is g. By the way, what is f? F of n is equal to, it has two answers. The first one is 2n minus 1 if n is even. And the other answer is 2n plus 2 if n is odd. By making use of that one, we are supposed to have the range of g of n. Yes, case 1. N is even. What happens to g of n in this case? N is even. If n is even, automatically n plus 1 is odd. Therefore, g of n in this case will be f of n plus f of n plus 1. Observe here. In this case, what is n? Even. In the case of even numbers, f of n becomes 2n minus 1. That is 2n minus 1 plus n plus 1 is odd. As this is odd, we are supposed to use this definition. So, 2n plus 2. Hence, f of n plus 1 is 2 into n plus 1 plus 2. Let us get it simplified. 2n, 2n, 4n. Next, 2 ones are 2, 2 plus 2, 4, 4 minus 1, 3 altogether. This is 4n plus 3. So, when n is even, g of n has become 4n plus 3. It is our duty to deal with the other case also. That is, what happens when n is odd. We are supposed to give the picture of g of n in both the cases. We have already seen the nature when n is even. It is now our duty to have its nature when n is odd. If n is odd, what is n plus 1? Even. N plus 1 is even. Here also, g of n. What is g of n? F of n plus f of n plus 1. F of n plus f of n plus 1. Therefore, g of n is equal to, let us observe the different cases here. What is the nature of n? N is odd. When n is odd, what is f of n? 2n plus 2. So, in the place of f of n, we are supposed to write 2n plus 2. And then, what is n plus 1? What is n plus 1? N plus 1 is even. When n is even, the definition is 2n minus 1. Here, in the place of n, we are supposed to have n plus 1. Have it plus 2 into n plus 1 minus 1. Let us calculate it once again. 2n, 2n, altogether 4n, 2, 2 ones are 2, 2 plus 2, 4, 4 minus 1, 3, 4n plus 3. Therefore, g of n is equal to 4n plus 3. Observing these two cases, in case 1, g of n is 4n plus 3. In case 2 also, g of n is 4n plus 3. What can you decide? G of n is equal to 4n plus 3 for all n belongs to n. That is, the range of g is set of all natural numbers of the form 4n plus 3 or 4k plus 3, as it is given in option C. In option C, he is saying us set of all natural numbers which are in the form 4k plus 3. Let us use k instead of n. What is there? Therefore, the right option among the given 4 options is the third option. Range of g is the set of all natural numbers which are in the form 4n plus 3 for all n belongs to n. That is, what is the right option? Third option is the right option. Let us see the next question. He is asking us to find the domain of a function. The function given is f of x is equal to square root of 10 minus again square root of x power 4 minus 21x square. And 4 options are given. The first option is closed interval 5 to infinity. Second option is closed interval minus root 21 to plus root 21. Third option is closed interval minus 5 to minus root 21 union root 21 to 5 union singleton 0. And the fourth option is minus infinity to minus 5. These are the options given. Let us observe the nature of f of x very carefully to trace its domain. What is f of x? F of x is 10 minus root of x power 4 minus 21x square. Here we have to see these two square root symbols simultaneously and very carefully. First of all, x power 4 minus 21 x square is available in this root symbol. Therefore, we must have x power 4 minus 21 x square must be greater than or equal to 0. Again, here 10 minus root of x power 4 minus 21 x square is greater than or equal to 0. You have to study both these two, the domain of x for which both these two conditions are valid, and to find the intersection of those two regions in which these two inequalities hold good. Let us concentrate on the first one. X power 4 minus 21 x square is greater than or equal to 0. That is x square into x square minus 21 greater than or equal to 0. Here, two cases may arise. X square, no doubt it is positive. Here, two cases now arise. What are the cases? X is equal to 0 or x square minus 21 greater than or equal to 0. This x square minus 21 can be read as x plus root 21 into x minus root 21. That is x plus root 21 into x minus root 21 greater than or equal to 0. It means that x does not lie between minus root 21 and plus root 21. That is, x belongs to minus infinity to minus root 21 union root 21 to infinity. In this inequality, we are able to observe two things about x. One thing, x may be 0. Another thing, x may be in this interval. Well, let us now concentrate on that particular condition. What is going to happen? Look here, 10 greater than or equal to root of x power 4 minus 21 x square. This is positive, that is positive. Let us square it. Nothing is troublesome. 100 is greater than or equal to x power 4 minus 21 x square. Implies x power 4 minus 21 x square minus 100 less than or equal to 0. Am I right? Let us now have the factors for this. 25 fours are 100. 25 minus 4 is 21. Therefore, x square minus 25 into x square plus 4 less than or equal to 0. Here, x square plus 4 is absolutely positive. Perfect square, perfect square. This is absolutely positive. Therefore, to make this true, this must be less than or equal to 0. That is, x square minus 25 is less than or equal to 0. That is, x plus 5 into x minus 5 less than or equal to 0. From this, we can trace that x should lie between minus 5 and 5. That is, x belongs to closed interval minus 5 to 5. Now, you have to consider all the three things in our mind. X may be 0, x may belong to this interval, and x belongs to that interval also. By having the intersection of all these two, rather the union of all these, the clubbing of all these gives us the third option as the right option, that is x belongs to minus 5 to minus root 21 union plus root 21 to 5 union singleton 0. That is the domain. Hence, among all the available options, the third option is the right option, because here we may have to keep three particular things in our mind. Number one, in this x square is again a factor here. There will be a case when x equal to 0. The other thing is this 1, 2, 3. By keeping all these three things in our mind, we prepare the domain of the given function like that. Hence, the answer is option. Third option is the right option. F of x is equal to sine of integral part of x plus integral part of sine x, and 0 is less than x less than pi by 2, where that bracket function represents the greatest integer function this function can also be represented as, he has given 4 different options. In the first option, f of x is 0 if 0 less than x less than 1, 1 plus sine 1 if 1 less than x less than pi by 2. F of x is 1 by root 2 if 0 less than x less than pi by 4, and it is 1 plus 1 by 2 plus 1 by root 2 plus root 3 by 2 plus pi by 4 when pi by 4 less than or equal to x less than pi by 2. And the third option is, it is 0 when 0 less than x less than 1, and sine 1 if 1 less than or equal to x less than pi by 2. The fourth option is 0 if 0 less than x less than pi by 4, 1 if pi by 4 less than x less than 1, and sine 1 if 1 less than or equal to x less than pi by 2. So here we are supposed to observe all the 4 options and examine the validity of the function. He has given that f of x is equal to sine of integral part of x plus integral part of sine x, and 0 is less than x less than pi by 2. Let us now split that interval 0 to pi by 2 as 0 to 1 and 1 to pi by 2. In 2 parts, let us observe. First of all, let us try to find this, that is sine of root x. 0 less than x less than 1 is one case, and 1 less than x less than pi by 2 is other case. It is an easy matter to discuss with. If 0 less than x less than 1, then what is integral part of x? It is 0. It is 0. Implies sine of integral part of x is sine 0, 0. Well, when 1 less than x less than pi by 2, in this case, what is integral part of x? It is a number which is greater than 1, which lies beyond 1 point something, say, then its integral part is surely 1. Integral part of x is 1, implies sine of integral part of x is sine 1. Sine 1. Well, next, let us concentrate on the values of integral part of sine x. Integral part of sine x. We all know that sine x always lies between -1 and 1. And we are between 0 and pi by 2 only. X is restricted to lie between 0 and pi by 2. So, directly we can consider 0 to pi by 2. In this case, sine x is less than 1. Not less than or equal to 1, sine x is less than 1. Implies integral part of sine x is positive and less than 1. So, integral part of sine x is 0 in both the cases. But the function is f of x is this value plus that value. So, let us club these two. By clubbing these two, therefore, 0 less than x less than 1 implies f of x is equal to sine integral part of x plus integral part of sine x, that is 0 plus 0 is equal to 0. And in the other case, 1 less than x less than pi by 2 implies f of x is equal to, what is f of x? First part, sine integral part of x. Second part, integral part of sine x. Here, in this case, we have it to be sine 1. There, it is 0. As a total, sine 1 plus 0 is sine 1. Sine 1. Let us now check in what option we are able to see this. F of x is equal to 0 if 0 less than x less than 1, and it is sine 1 when 1 less than x less than pi by 2. It is possible to be seen in the third option. Therefore, the third option is the right option. Here, in noticing the correct answer, you must be knowing integral part of x and integral part of sin x also in the required domain. He has given that the domain of x is 0 less than x less than pi by 2, and it is wise to split that in two parts, that is 0 to 1 and 1 to pi by 2. Like this, we trace the answer to be the third option. The next question is, f of x is equal to x square minus 3x plus 4 by x square plus 3x plus 4, then the range of f of x is. What is the range of f of x? Actually speaking, it is comprised of two quadratic expressions. By clubbing those two quadratic expressions, we are supposed to have its range. The function given actually is f of x is equal to x square minus 3x plus 4 by x square plus 3x plus 4. We are supposed to have the range. Let us call it some y. Actually speaking, the procedure that everybody knows is by cross multiplying this, we shall be having x square y plus 3xy plus 4y is equal to x square minus 3x plus 4, and y minus 1 into x square plus 3y plus 3 into x plus 4y minus 4 is equal to 0. It is quadratic in x, hence as x is real, the discriminant must be greater than or equal to 0. Thereby we will be getting a quadratic inequality in terms of y, and solving that y we shall get the range of f of x. It is somehow time taking. Let us use our good olden mechanism. What is that? You compare this with a1x square plus b1x plus c1 by a2x square plus b2x plus c2. One can easily trace that a1, b1, c1 are 1 minus 3, 4. a2, b2, c2 are 1, 3, 4. Also, d1 discriminant of numerator, d2 discriminant of denominator, With this symbolism, what happens? d2 into y square plus 4 into a1 c2 plus a2 c1, a1 c2 plus a2 c1 minus 2 b1 b2 into y plus discriminant of the numerator greater than or equal to 0. What is d2? Discriminant of the denominator. What is the discriminant of the denominator? b square minus 4ac, that is 9 minus 16. What is that? Minus 7. a1 c2 plus a2 c1, 1 into 4 plus 1 into 4. What is that? 8. b1 b2, minus 3 into 3, minus 9. What is discriminant of the numerator? What is the discriminant of the numerator? What is that? 9 minus 16, b square minus 4ac. 9 minus 16, it is again minus 7, greater than or equal to 0. This is 32 plus 18. What is that? 50. Minus 7y square plus 50y minus 7 greater than or equal to 0. So that it is 7y square minus 50y plus 7 less than or equal to 0. And one can easily notice that this can be factorized quickly as 7y minus 1 into y minus 7 less than or equal to 0. It means that y lies between 1 by 7 and 7. 1 by 7 and 7. What is y actually? F of x. So, f of x belongs to 1 by 7 and 7. What is the range of that expression? 1 by 7 to 7. Is that closed interval available among the options? Surely the fourth option is the required option. Closed interval 1 by 7 to 7 is the right option. This is the way of having the ranges of such functions. Of course, there has been a customary procedure and habit to cross multiply it with getting a big quadratic equation in x, and then by using discriminant greater than or equal to 0, thereby getting a quadratic inequality in y, and hence solving them we arrived at that. So if you could use this mechanism, a piece of time will be saved. That's all. This is the answer. In this question, f2 into f of sin x plus f of cos x is equal to x for all x belongs to R. Then range of f of x is, where does it lie? That we have to learn. He has given 4 options again. First option is closed interval minus pi by 3 to plus pi by 3. Second option is minus 2 pi by 3 to pi by 3. Third option is minus 2 pi by 3 to pi by 6, and the fourth option is minus pi by 6 to pi by 6. Let us see. We are given 2 into f of sin x f of cos x is equal to x for all x belongs to R. We are supposed to have the range. Let us now play 2 different ideas. As it is true for all x belongs to R, in the very definition itself it has been given for all x belongs to R. In the first step, replacing x by sin inverse x. What happens? Replacing x by sin inverse x. What are you going to see? 2 into f of sin inverse x is x plus f of cos x. Cos x in terms of sin inverse x. What can you have? F of cos of, in the place of x we are having sin inverse x. For sin inverse x, we can write cos inverse root 1 minus x square. Cos of cos inverse root 1 minus x square is f of root 1 minus x square is equal to sin inverse x. Call this equation 1. To get this, the main idea behind this step is just to have f of x at a glance. That's all the reason. Again, replacing x by cos inverse x, what do you have? 2 into f of sin of cos inverse x, as in the previous case. In the place of x, we are supposed to have cos inverse x, but cos inverse x is sin inverse root 1 minus x square. Sin of sin inverse root 1 minus x square is root of 1 minus x square, and cos of cos inverse x is x is equal to cos inverse x. Now the plan is to eliminate f of root 1 minus x square from these 2 equations. Thereby we shall be getting f of x directly. We will be able to see what f of x is. If f of x is seen clearly before you, then you can think of its range very easily. This is the plan behind this procedure. Well, I would like to eliminate f of root 1 minus x square. How can it be done? Multiply the first equation with 2. What happens? Let us see. First equation into 2 implies 4 into f of x plus 2 into f of root 1 minus x square is equal to 2 sin inverse x. And do not do anything about the second equation. What does that second equation say? F of x plus 2 into f of root 1 minus x square is equal to cos inverse x. Let us subtract this from this equation. What are you going to have? 3 into f of x is equal to 2 sin inverse x minus cos inverse x. Minus cos inverse x. We know that sin inverse x plus cos inverse x is pi by 2. Therefore, in the place of cos inverse x, what can you write? Pi by 2 minus sin inverse x. This is 2 sin inverse x minus pi by 2 minus sin inverse x. So that it is 3 sin inverse x minus pi by 2. We are happy. We are able to get 3 into f of x, and hence f of x can directly be estimated as sin inverse x minus pi by 6. Sin inverse x minus pi by 6. Again, we know that sin inverse x ranges between minus pi by 2 and plus pi by 2. Therefore, this lies between minus pi by 2 and plus pi by 2. Therefore, the minimum value of this is produce minus pi by 2 in the place of sin inverse x. Minus pi by 2 minus pi by 6. What does it mean? Minus pi by, but minus pi by 2 less than or equal to sin inverse x less than or equal to plus pi by 2. Subtract minus pi by 6 on all the sides. Minus pi by 2 minus pi by 6 less than or equal to f of x less than or equal to pi by 2 minus pi by 6. It is just nothing but minus 2 pi by 3 and pi by 3. Implies f of x belongs to, what is that? Minus pi by 2 minus pi by 6 is nothing but minus 2 pi by 3, and that is pi by 2 minus pi by 6 is just nothing but pi by 3. What is the range of this function? Minus 2 pi by 3 to pi by 3. The basic idea here, which helps us a lot in tracing f of x, first of all, is this. Replace x by sin inverse x first of all and then cos inverse x, so that f of x will be seen clearly before us, ready on the desk before us. That is f of x. We know pretty well about sin inverse x. Thereby, we know that f of x ranges between minus 2 pi by 3 and pi by 3. That is, the second option is the right option. Second option is the right option.